Hello guys, this is Ranga Rosvaru. Today we are going to discuss about the glycolysis process. Last time we discussed about how the carbohydrates undergo digestion in the digestive system. After the completion of the carbohydrates digestion in our digestive system, that absorbed into the blood. After the absorption, it's entered into the cytosol. Okay, it's entered into the cytosol. How the process after entering into the cytosol, how the carbohydrates undergo the process, let me see, and how that give the energy to our body. Okay, here we discuss about the glycolysis. Okay, glycolysis. Okay, so last time we discussed that after in the small intestine, for example, it was a small intestine. After here the projections present, finger like projections. Okay, small intestine. Okay, here in this microvilli, for example, this is the what is this? This is the microvilli. Okay, this is the microvilli. Okay. Okay, here how the microvilli is present. For example, this is the microvilli. In this blood vessels present, and also lacteals, lymph vessels. Some are lymph vessels present thick. These are the thick lymph vessels. Okay, here, for example, these are the blood vessels. Blood vessels. These are the lymph vessels. Okay, lymph vessels. After the completion of the digestion of the carbohydrates in our digestive system, these are absorbed into the blood through the microvilli. Here blood vessels present, right? Entering into it, it's through the, then after it's passes to the heart and is circulated to the different parts of the body. There, after transporting to different portions of the body, these glucose molecules. Okay, what are the macromolecules of the carbohydrate converted into the micromolecule? That is the glucose, right? So these molecules undergo the further process in the cytosol. Now, after entering into the cell, what it was cell. Okay, what it was cell. What it was nucleus. Okay, nucleus. This is called the cytosol portion. What it was cytosol portion. Here, this glycolysis process takes place in the cytoplasm. Where it will take place? Cytoplasm. What it was? Cytosol. Why I am calling this one as a cytosol? You know that if the cell organelles present in the cytosol, what we call to that? What we need to call the cytoplasm. But what we are showing here, without the cell organelles, we are showing here. That's why I am calling it one as the cytosol. Okay, right. Okay, let me see the glycolysis first of all, how it will happen. You know that glucose have this is the 6 carbon molecule. What it was? 6 carbon molecule. For example, C-double-bond-O. Okay, what it was? This was the glucose. What it was? This is the glucose. Okay, right? See here. How many carbons is here? 1, 2, 3, 4, 5, 6. This is the. That's why I am calling this one as a 6 carbon molecule. What it was? Aldehyde. What was? Aldehyde group. Okay. C-double-bond, we are calling this aldehyde group. Okay. This is the linear structure of the glucose. What is the structure of this one? It was in the linear structure. Okay. Now, this glucose, it turns into the hemiester form. Before it turns into the cyclic form, let me step by step. Let me discuss more details. Okay. This is the glucose. Then after it turns to the let me see the cyclic structure of the glucose. Hemiester form. Let me see. Here what will happen? Okay, this this fifth carbon, okay, and form bond with this carbon aldehyde group. Okay, this aldehyde group and the fifth carbon form a bond. Okay, let me see here. See, when it was form the bond, then it will be the it breaks the bond here. Okay, CH OH. Okay, here, right, what will happen here when the bond breaking is become single? This is OH. Now there is a what is the valency of this carbon? It can form the 4 bonds, right? It valency 4. So now it forms bond with this one. Okay, this is called a hemi-acetal form of the glucose. What it was? Hemi-acetal form of glucose. Okay, this is the linear structure. We are gradually converting into the cyclic structure. Okay, next one is the hemi-acetal form. Then after this hemi-acetal form, from hemi-acetal form, let's see the cyclic structure of the glucose. Okay. Okay. Here, all the right side things will come down, and the left side things come up. Okay. This one, see the left side, right? It will. We are writing this one upside. Okay. Hydrogen group H. Then after on the fourth carbon H and OH. Then after fifth carbon here the H. This group will come up on this CH2 OH. What is the cyclic structure of the glucose? Glucose cyclic structure. Okay. This is the linear structure. Turns into the hemi-acetal form of the glucose. Then cyclic form of the glucose. What is this? Cyclic form of the glucose. Okay. Clear, right? See here. Let me write cyclic form of the glucose. Okay. What is this? Ethanol group. Okay. This is the cyclic form of the glucose. Now, after entering of this glucose molecule into the cytosol of the cell, the glycolysis process will begin. Okay. Now, what will happen in the glucose in the presence of hexokinase? What will happen? What is the hexokinase? For the activation of this enzyme, divalent magnesium ions is required. Okay, divalent magnesium ions is required. Without the magnesium ions, it can't work properly. Okay, here hexokinase. When hexokinase comes, the ATP. The ATP will form here. In the presence of hexokinase, glucose turns to glucose 6-phosphate. What it will turn? Glucose 6-phosphate. CH2 glucose 6-phosphate. Okay. What is is glucose 6-phosphate. Okay, in the place of hexokinase, here the phosphate group is replaced by the phosphate group in the presence of hexokinase. Okay, what it was? Glucose 6-phosphate. What it was? Glucose 6-phosphate. Glucose turns to glucose 6-phosphate in the presence of hexokinase. Hexophosphate isomer. Then after, when it turns glucose 6-phosphate in the presence of hexophosphate isomerase. One more enzyme. What is that? Hexophosphate isomerase. The presence of hexophosphate isomerase is converts to isomerization. Okay, this is the phosphorylation step. What is this? Phosphorylation step. This is isomerase. That's why we are calling this enzyme as the hexophosphate isomerase. Okay, what will happen here? Now this glucose 6-phosphate is converts to fructose 6-phosphate. It turns to fructose 6-phosphate. Okay, what will happen here? This moves up, this will be the compound. Okay, same, everything is then same. First carbon, second carbon, this is the third carbon, right? Right. Okay, same, all are same. This is the fifth carbon, right? Says to OP. Okay, what is this one? In the presence of hexophosphate isomerase, this glucose 6-phosphate turns into the fructose 6-phosphate. Okay. Fructose 6-phosphate, when the glucose 6-phosphate turns to fructose 6-phosphate in the presence of hexophosphate isomerase, this fructose 6-phosphate, when it is exposed to, subjected to the phosphofructokinase, when it is subjected to enzyme phosphofructokinase, what the enzyme name? Phosphofructokinase. Phosphofructokinase, it turns to fructose 1,6-bisphosphate. No, fructose 6-phosphate turns to fructose 1,6-bisphosphate. Okay. Here, one more ATP will be used here. ATP turns to ADP. Okay. Here one difference of ATP gives the phosphate to this. Okay. Here fructose 1,6-bisphosphate. Already we have the phosphate here, CH2OP. Same structure. Here you can see. Previously there is no phosphate here at the first position. Okay, when it is exposed to the phosphofructokinase enzyme in the presence of enzyme by utilizing ATP, here will be the phosphorylation step. Okay, where the phosphorylation is going here. Okay, fructose 1,6-bisphosphate. What is the name of this molecule now? Fructose 1,6-bisphosphate. Okay. Now, when this fructose 1,6-bisphosphate exposed to the aldolase enzyme, what the enzyme? Aldolase. aldolase enzyme, now it gives the this is the here the fructose 1,6 bisphosphate cleaved into the two molecules, that is glyceraldehyde 3 phosphate and dihydroxyacetone phosphate. These two molecules are the 3 carbon molecules. What are, how many carbon molecules are these two? 2 carbon 3 carbon molecules. Okay, this fructose 1,6 bisphosphate is cleaved to two molecules, that each molecule is made up of 3 carbons. Okay, you have to see here. The presence of aldolase, glyceraldehyde 3 phosphate. The aldehyde means there should be aldehyde group CHOH, glyceraldehyde 3 phosphate. This is the one molecule it's given, glyceraldehyde. Glyceraldehyde 3 phosphate. The presence of triose phosphate isomerase. What is the enzyme? This is the one molecule. Okay, another molecule is dihydroxyacetone phosphate. Dihydroxy. Okay, this is called dihydroxyacetone phosphate. Okay, what is this? This is the second molecule. Okay, now this fructose 1,6 bisphosphate is cleaved into two molecules. First one is glyceraldehyde 3 phosphate, next one is the dihydroxyacetone phosphate. These molecules are made of how many carbons? Okay, 1 2 3 3 carbon molecule, right? 1 2 3 3 carbon molecule. Okay, then here is one more enzyme. It is useful to interconversion. Okay, that is called the triose phosphate isomerase. Triose phosphate isomerase. What is the role of this enzyme? After the cleaving of the fructose 1,6 bisphosphate in the presence of the aldolase enzyme, that one are glyceraldehyde 3 phosphate and dihydroxyacetone phosphate. Okay, now glyceraldehyde 3 phosphate again it turns to glyceraldehyde 3 phosphate in the presence of triose phosphate isomerase. Then after these molecules undergo the further process. Okay, further process. Okay, here. This is called glyceraldehyde 3 phosphate. Glyceraldehyde 3 phosphate. Okay, in the presence of glyceraldehyde 3 phosphate dehydrogenase. What is the enzyme? Glyceraldehyde 3 phosphate dehydrogenase.